What justifies statistics' role in data science? 9.41 million out of the total 16.3 million people have recovered from the coronavirus. What does the statistic indicate? Anyone may clearly deduce that the majority of people are getting better from the coronavirus. Statistics facilitate drawing conclusions from vast amounts of data. What function does statistics serve in data science, then? Well, it's rather obvious at first glance. Since this field centers on the collection, transfer, analysis, and practical use of data, statistics are essential. They are crucial for organizing the raw data and figuring out how uncertain it is. Naturally, you must possess strong coding and programming skills. But how strong of a strength should statistics be for you? What career paths are open to you in data science if you excel at statistics? Let's investigate. What connection exists between data science and statistics? In its earliest forms, statistics in data science seeks a structure and connections among various unflustered data. The data's structure can be used to reveal a variety of insightful information. For instance, understanding the proportion of those affected in a medical emergency can assist you come up with solutions. Similar to this, categorizing your customers into different age groups will help you create adverts and obtain a better understanding of your target market from a data science perspective. However, you cannot discover these realities by gathering isolated, unrelated data. Statistics use tools like pie charts and bar graphs, among others, to portray the data in structured formats. Data science applications of statistics to do his duties properly. Every data scientist and analyst must understand the following ideas. Classification. Classification is an umbrella term for data mining methods. In this procedure, we divide the data into subsets depending on a number of different criteria. Finally, we can segment the data using patterns established in data visualization and sampling. These criteria may be ones we discovered through research. They may be based on our aims. Credit. 3 important techniques are used in classification, which is sometimes known as a decision tree: k-nearest neighbors, logistic regression, and linear discriminant analysis. In data science, classification is frequently used. Similar to how data scientists and analysts must constantly determine how to categorize emails as important or spam, AI categorizes news based on your past searches and read-through rates, among other things. However, the 3 methods of classification that were covered above are not the only ones. To predict the qualitative replies as accurately as feasible, your system and procedures would need to be updated on a constant basis. Online statistics courses can be very helpful and time-saving if programming is your strong suit and you want to work in data science. Logistic regression. Logistic regression, one of the most often used classification techniques, aids in the prediction of qualitative responses using patterns that have been noticed. Based on their relationship and the values of other variables on the graph, the procedure forecasts the values of a variable whose values are currently unknown. The procedure isn't as easy as it seems, though. The goal of logistic regression is to determine which relationship, between the dependent and independent variables in the graph, is the most closely related. The method is used in data science in the disciplines of machine learning, social sciences, and medicine. For instance, using logistic regression, the trauma and injury severity score forecasts the fatality rate. AI is also capable of determining whether an image comprises a cat, dog, person, etc. Resampling techniques. It is a common technique for performing accurate and unbiased analysis on big data sets. The method removes population parameter uncertainty during the processing of enormous amounts of data. In order to create a tiny and distinct sampling distribution that accurately represents the original data, the approach continuously selects samples from large amounts of data. The method encompasses all potential study outcomes, increasing accuracy and reducing prejudice. Benefits of statistic learning for data science. 1. Aids in arranging the data. Companies must accurately classify data in order to create marketing strategies. Additionally, the organization's ability to focus on improving its products and services is aided by the categorization and structure of data. In data science, unorganized data is useless, a waste of time, and an asset. 2. Helps identify trends. The process of gathering data can be intellectually, physically, and financially exhausting. You may shave off a ton of time and money by conducting focused research. Data scientists can correctly focus their topic of research by identifying trends early on in their study with the aid of statistics. 3. Aids in probability distribution and estimate. Logistic regression, cross-validation, and other techniques that help the machine predict your next move are the foundation of data analytics and machine learning. Consider the suggested songs when you are listening to music on YouTube. Even if you haven't heard any of them before, you're likely to find at least a couple that you like. 4. Facilitates data visualization. When it comes to big data analysis, visualization techniques like histograms, pie charts, and bar graphs are at the top of the list for making data more engaging and enlightening. They offer an engaging and simple method of interpreting complicated data. These statistical techniques enable even the layman to understand patterns and identify them early. Finding conclusions and creating action plans becomes simpler as a result. 5. Encourage fewer assumptions. The fundamentals of AI, machine learning, and data analytics are derived from a familiarity with differentiation and continuity in mathematical analysis. These variables aid in predicting outcomes using specific inferences rather than broad generalizations. Statistics reduces assumptions, improving the model's ability to forecast the future. We have reached a stage where a large portion of what we view is pertinent and probably associated with what we want to see, and this hasn't happened by magic. 6. Assist in accounting for data variability. In model-based data analytics, statistics can take into consideration a number of variables, including clusters, time, geography, etc. Without using statistical procedures, data might be analyzed without taking unpredictability into account, which can reveal inaccurate estimations. Understanding distributional approaches also improves one's understanding of the variable factors. In addition to visualization, the means of distribution are crucial in both data analytics and statistics. Is statistics the only aspect of data science? Although statistics are a crucial component of data science, that is not the only skill you must master. A wide range of disciplines, including mathematics, probability, programming, and statistics, were necessary for data science. Depending on the position you wish to fill, you may need a certain level of experience in a variety of subjects. To succeed in any of those roles, you'll need to have at least a fundamental understanding of all these subjects. The next step is specialization. If you want to work in machine learning or as a statistician, you must be an expert in statistics. Conclusion. Thus, statistics has had a significant role in the development of data science to the point where it is today. Any algorithm, large data analysis, or targeted market research has to have a basic understanding of statistics. Perhaps the best instrument for comprehending, interpreting, and drawing conclusions from data is statistics. Conclusion. It is not necessary to enroll in another 3-year program to have the necessary statistical knowledge for data science. To advance your job, you might choose to take courses from educational organizations like Business Toys.